welcome to our final video in the series, Session 8 of the Quantum Youniversity Foundational Course. In this session, we're going to look at absorption and assimilation, essentially the digestive system, and also the respiratory mechanism, our breath. And really, I look at both of these ideas, these concepts in the body, as a form of information exchange. When we breathe in, we are breathing in some of the field around us. We are ingesting it, and in this instance, bringing it into the lungs. And then we assimilate that information. We have different gaseous exchange mechanisms going on in the body. And then we exhale information back into the world around us. And as we know, we're breathing in oxygen. We breathe out carbon dioxide, and all the plants and trees around us can use the carbon dioxide and then breathe out oxygen. So it is an information exchange. In the same way, when we eat, we are eating pieces of information that we can use in our body to either build ourselves with or to use for energy, and then we excrete different particles out of the body. So there's this constant conversation going on. I like to think of it as a handshake. Now, we've been invited over recent years to believe that we are surrounded by a sea of what look like tumble dryer balls, like in this image here, that are all out to attack us and to cause trouble with our body, and that we have to take all these measures to be able to come into harmony with them. But if you just think of the environment around you as just being part of you, we've seen we are all part of this greater field, and that really all we're doing is having a conversation. Now, you might be around somebody who you really get on with and they give you really stimulating conversations, and so you're eager to exchange with them. They tell you things, you absorb it. You might go, oh yes, that's great. Or you might say, actually, no, I don't believe that, and here's what I believe. It's the same mechanism. All we need to know is, are we in alignment with that information, or are we not in alignment with that information? And if we're not, we may choose to move away from it, or if it's unavoidable and it still comes into our system, do we have a system that's robust enough to be able to either assimilate that information and neutralize it, or to push it out via the excretory pathways of the body? So if we just think of all of these interactions as an information exchange, then it becomes a lot simpler to understand. So let's take a look first at the digestive system and which parts of our body are involved in digestion. So we're talking here about the ingestion of food particles, and we talk about something called the gastrointestinal tract, or GI tract, you might have heard it described as. And this really is a hollow tube that begins in your mouth. Obviously, that's the port of entry for our food particles. It then goes down the long feeding tube known as the esophagus, which runs from the mouth down to the stomach via the pharynx that we talked about in a previous session. That's essentially the throat area. Then after the stomach, we then get into what are known as the intestines. So gastro, that word refers to the stomach. Intestinal refers to the intestines, which is the kind of wiggly bit that goes all the way around many corners and then eventually exits via the anal canal at the other end. So if you think of that tube as being hollow, which it is, essentially it is a piece of outside space. Anything that is in that tube is considered outside of the body until such time as it has been absorbed through the walls of the intestines. So we're going to see in a moment we have the small intestine and the large intestine, and this is really where the absorption takes place, where the body decides, am I in alignment with this information and can I use it and bring it into the body at large, or am I just going to move it through and out the other end? So Just like our toroidal dynamics, that funnel down the centre of the torus field being that tube, that funnel, then the centre of our digestive tract is like that, even though it takes a few more wiggles and turns on its route. Anything that is inside that digestive tract is outside of you until we have decided it's safe to let it enter. Remember, we're talking about a handshake, and remember, I always say that the body is just saying yes or no. Yes, this is good, I can use this, or no, I will pass and we'll move it through the system. So that's the main geography of the GI tract, and we're going to look at each of those segments in more detail in a moment. But we also have what are known as accessory organs to digestion. So things that are not actually part of that hollow tube, but they assist and help and connect into the digestive tract to help with digestion. So first of all, in our mouths, we have what are called the salivary glands. You're probably familiar with the idea that when you put food into your mouth, or even sometimes if you just smell very aromatic food, you start to secrete saliva into your mouth. And we have these little glands around the chin, jaw area that produce that saliva and squirt it through little gaps in the lining of your mouth into the oral cavity, because your digestion starts there. That saliva that's excreted contains enzymes that start to break down the food in the mouth while you're chewing. The liver, the big organ on the right side of the body, is also part of the digestive system, although it has other functions in the body as well. It also produces digestive enzymes which go via the gallbladder just below the liver and via the bile duct into the intestine. So the bile duct, by its name, carries bile. So bile is that bitter substance that has more digestive enzymes that will help to break down the food products in the small intestine. Our pancreas also helps with digestion by also secreting more digestive enzymes. And then, of course, the teeth and the tongue are also part of digestion because they start to break down the food and turn it into a little ball that's called a bolus, so that it's small enough and soft enough to be passed down the esophagus into the stomach. You all know if you haven't chewed your food properly and you swallow it too soon, it can be very painful as it passes down that feeding tube. So those are all the players that help and assist with the digestive process. So let's look at the first part of that journey from the mouth to the stomach. So we mentioned there the teeth and the tongue are there shaping the food and breaking it down. And here's a great image of those salivary glands just in front of your ear there and also just under the jaw and the tongue. And they're going to squirt that digestive enzyme juice into the mouth. And if you've ever had that time when you smell some delicious food and you can almost feel a pain as those glands start to squeeze the juice into your mouth, so that's a time when you're actually aware of it happening. Then that bolus of food is going to be swallowed, so the squeezing mechanism of the pharynx, those muscles of the throat there, are going to push the food down that little pipe that goes into the stomach. And the stomach is kind of kidney-shaped, ironically, and it lies slightly on its side. At the top, where the esophagus meets the stomach, there's a little valve in there, and that's called the cardiac sphincter. Cardiac is like the heart because it's actually right by your heart. And if anyone's ever had acid reflux, that little valve is misfiring and it squirts some of that stomach acid back up into the feeding tube and causes inflammation. And it can often feel, if anyone's ever experienced it, almost like a heart attack. You get a burning pain right in the middle of the chest there because that valve is right next to the heart. That's often also known as a hiatus hernia, in case you've heard that term. So once that little valve opens, receives the food into the stomach, the walls of the stomach excrete acid, and this is hydrochloric acid. If you were to get that stomach acid on your skin, it would burn. So this is a high acid environment because it's going to really break down that food into a more digestible form. So there's a lot of churning that goes on in the stomach, and the food particles can be in there for up to 4 hours. So it's almost a bit like a washing machine. There's acid being squirted in, and then it's being churned around so that it breaks it down into a pulp. Then once it's ready to be moved on, there's an exit point via another little valve, and this is known as the pyloric sphincter, and that opens and squirts the now digested pulp down into the small intestine, which is the next stage of our journey. So this is why if you've eaten food, it's best to sit upright for a while, because that food's going to be churning around for about 4 hours. If you lie flat straight after eating, gravity will push some of the highly acidic stomach contents up against that cardiac sphincter, and it can irritate it and cause it to open when it shouldn't be. And it squirts some of that acid back up your esophagus into the mouth, and that can aerosolize and actually fall down the airway as well. Remember, we've got 2 pipes in the throat area. And that acid can actually even land in aerosolized form on your vocal cords. So this is an issue for some of the singers that I work with who, if they're suffering from acid reflux, it can affect their vocalizing. And typically performers like to eat really late at night after a show, and then they go to bed, and so they're more at risk for reflux. But now we're heading the other way, and we're going to see what happens next on our journey. So now we're into the small and large intestines, which is the wiggly bit of our digestive tract. In fact, if you were to unravel the entire digestive tract of the average person, it can be up to 30 feet long. So there's an awful lot of tubing all curled up and packed into the abdominal cavity. So this is why, as humans, because we are also up on 2 feet, with gravity kind of squishing down on these internal organs, why we tend to have quite a lot of digestive problems. If you're an animal on all fours, the digestive tract is actually swinging in space as you move around. It's hanging downwards, and it's actually more biomechanically advantageous for digestion. So now if we look at this small intestine, this is the bit in the centre of this image, and it itself is divided into 3 segments, which all have different colours in this picture. So the first part that comes off the stomach and does the first little wiggle and is yellow in this picture is called the duodenum, or in the US you tend to say the duodenum. Then the next section is the purple bit, the middle bit, and that's called the jejunum, very similar to duodenum, and that's that middle section. And then we have a final section, the pink one in this image, called the ileum, and it's ileum with an E, not with an I. The ileum, I-L-I-U-M, is the hip bone, but the ileum is the lower part of the small intestine. And so each of those sections have slightly different jobs in the digestive process, but this is the sort of production line that our food is going through. So this small intestine is where 90% of food absorption happens. So this is really where we get our money's worth from what we're eating. That duodenum is going to receive secretions from the liver and pancreas. Remember, we mentioned that they're squirting out some digestive enzymes to help. So that happens in that first part. Then in the jejunum, the middle part, this is where the main digestion and absorption occurs. So this is where that information exchange is at its height. And then in that terminal part of the small intestine, the ileum, that's where further digestion and absorption takes place. So remember, one of the mantras of digestion, particularly for people who have digestive issues, is it's not what you eat, it's what you absorb. So no matter what you've eaten, unless it passes the checks and balances of this small intestine, it will not be absorbed into the system. Then the next part of the intestine is known as the large intestine, or the colon, and this goes all the way around the abdominal cavity surrounding that small intestine. So we actually have an ascending part of the colon that goes upwards from that lower right-hand part of your body. And again, we have a little valve there between the ileum and the colon, and it's known as the ileocecal valve. If anybody's had constipation, things can get a little bit jammed up around that valve there, and as osteopaths we can use manual techniques to help to relieve congestion there and help to improve the function of that valve. So then the remaining food particles have to go upwards, up along the ascending colon, then it turns 90 degrees and goes crosswise, and that's known as the transverse colon. Then it goes down the left side of the body, the descending colon, and then down to the anal canal and then out the other end. In the large intestine, the main thing that's happening here is water absorption. So this pulpy mass is still quite liquid, and we need to turn it into a more solid form to be able to excrete it. So in this large intestine, the main function here is to pull back some of the water, also because we don't want to dehydrate ourselves too much. And then there's some final bits of digestion. It's the last chance for the body to say, oh, actually, no, I will take that bit. And it'll pull that into the body, and then whatever is left gets excreted through the anal canal. So that's why if you've ever had the opposite of constipation, where you've got a loose stool, you can end up being quite dehydrated. You're losing too much water. So the large intestine is responsible for making sure we reabsorb some of that water so that we don't dehydrate ourselves too much. So that's the anatomy of the digestive system. Let's now take a little closer look at what's happening in the small intestine where that absorption is taking place. And we're going to talk here about our gut lining. So this is a very precious piece of our body, and one that can get into trouble with a lot of people who suffer from some form of digestive discomfort. Now, we've talked about the cells of the body before when we looked at the layers of the skin through the fascia. And in the area of the skin, for instance, the cells are quite thick there. We have several layers. In the gut, the small intestine in particular, the lining of the wall, remember this is a hollow tube, and it is the cells that line the walls of that tube that decide what comes in and what stays out. This lining is only 1 cell thick. So this is why it's very delicate and can get into trouble if we're eating things that are irritating it. Imagine if your skin on the outside was only 1 cell thick. You'd end up with lots of cuts and bleeding areas all the time. The skin would be too fragile. So this is a very fragile area of the body that's making very nuanced decisions about what to bring in and what to keep out. I always talk about the lining of the gut as requiring a high degree of discernment. And as we've seen before, our emotions dictate our physiology and the behaviour of our physiology. If you tend to have very leaky emotional boundaries, then you can end up with that being reflected in the boundaries of the digestive system, and we can end up with leaky gut, which we're going to talk about here. So let's have a look at these cells in more detail. And what you'll notice is they are little kind of vertical structures, and they've got what looks like a spiky hairdo on the top, like little hairbrush bristles sticking up. Those are there to increase the surface area. If you imagine that cell just had a flat roof on it, then it's not very long. It's the width of 1 cell, and these cells are pretty tiny. But if you've got these little bristles that go up and down, and you now take a little walk up and down the hills and troughs of those little bristles, it's a much longer journey. That gives us a greater surface area for absorption. So these are known as the villi and the microvilli. It's also known as a brush border on the top of those cells. So now we've got a lovely increased area for absorption of this food. Underneath that layer of cells, you'll see we have the blood capillaries there. So this is the bloodstream. So these little cells, remember only one layer thick, are the gatekeepers of what is going to get into the bloodstream. So this is where we need a high degree of discernment, because whatever gets into the bloodstream can cause trouble anywhere in the body. It's now got free access to the whole body, so we want to make sure that whatever's coming in is useful to us. So the blood is obviously going to carry that absorbed food away and off to its target destination for either repair or for breaking down into energy. We also have some lymph vessels there. Remember that from our session on the circulation of the fluids. And those lymph vessels are there to also do a little bit of drainage. Remember, that's part of their job too. So if there are unwanted particles, they can be pushed into the lymph system and be excreted via the kidneys, for instance. So these little cells, you can almost think of them as sentries. Now, remember when I talked about the immune system, I said we tend to use a lot of militaristic language around defense and attack and all that sort of thing. So I am recognizing that the example I'm using here is a little bit militaristic. But if you imagine a row of soldiers all standing shoulder to shoulder and they're told bunch up tight, don't leave any gaps between your shoulders, because the food particles need to go via that little brush border and through the cell itself, because that cell is going to run through the checks and balances. It's going to check the paperwork of the food particle and say, yeah, you pass, you may go through, or no thank you, you're going to stay on the other side, the outside, which is your inside. And where one cell meets the next cell, this is known as a tight junction. So it's making sure that nothing's going to squeeze through the gaps. However, if you've ever had leaky gut, what happens is those tight junctions are not so tight, and we end up with little gaps between them. What that means is that some of those food particles can sneak in and get around the checks and balances of the gut lining and get themselves into the bloodstream without being checked first. So the discernment that these little cells are having to make is really between whether something is food or non-food. The things that we eat need to be recognised by the body in order for them to be broken down. So if something comes in that's not actually harmonic with the body, we don't have the enzymes to be able to break it down enough so that it's safe to be passed into the bloodstream. So some highly processed foods really don't pass the bar of what is food and what is non-food for our gut to be able to assimilate it. So anything that isn't able to be processed can lead to inflammation around this gut lining. The body doesn't want it to come in, and remember when we looked at the immune system, we will mount a response to things that are not in resonance with our body tissues, and that can involve inflammation. If we remember, in our sympathetic nervous system response, the digestive system is switched off and inflammation is brought online, because the inflammatory environment may be able to break this thing down so that it's not going to be harmful for the body. This is going to alter what's known as the microbiome. You might have heard that term. This whole area of the gut is coated with little bacteria, little organisms that help with the digestive process. They're there to actually help break down this food. However, if they get irritated with inflammation, then it's going to alter that microbiome, and as we'll see, that's going to lead to potentially a broader inflammatory response throughout the body. So leaky gut is when those tight junctions become a bit gappy. some of the food gets through the gaps, and then we mount an inflammatory response in order to stop those particles getting through to areas where they could do more damage. So it is a useful response, but it always comes back to the idea that is it an appropriate response and is it a proportionate response? You may be eating the most beautiful organic diet with no inflammatory markers in it at all, but yet you're still having digestive issues, an inflammatory response. And we'll talk about that in a little more detail later as to why that might be happening. But here now we can understand how the gut operates, how that absorption takes place, and what the checks and balances are to keep us safe. Now, we looked at the nervous system before and the various different branches it has, but there was one that I saved until this session, and it's called the enteric nervous system. If you think of the word gastroenterology, gastro we saw was the stomach, entero refers to the intestinal area, so the enteric nervous system is the nerve complex that operates this gut area. Now, essentially, the gut has its own brain. This enteric nervous system is actually self-sustaining. The only structure that connects the gut brain to the cranial brain in our head is the vagus nerve, or the two vagus nerves, and we'll talk about that in a moment. If you actually sever those vagus nerves and cut off the supply to the gut from the brain in your head, the gut will still operate. It is actually a self-functioning system. Now, when we look at the vagus nerve connection, you remember we've got a right one and a left one that come out of the lower part of the brain. Remember, not via the spinal cord, because these are cranial nerves, cranial nerve number 10. So those two vagus nerves come down and they go and serve many different parts of the body, the heart, the lungs, but they come down and connect into this big web-like complex of nerves that serve the gut. Now, if you remember our cross-section of a nerve, and we saw that within that one cable there are many different fibres and filaments, and the traffic could be going up to the brain or back down from the brain. Remember our afferent and efferent pathways. When you look at a cross-section of the vagus nerve and see which way the traffic is going in those little fibres, 80% of the fibres carry information from the gut to the brain in the head, the cranial brain. Only 20% of the fibres go the other way. So I always say, who's really in charge? We talk about gut instincts and following your gut. This is a physiological truth because our guts are actually the main arbiters of whether we feel safe or not. And if there is an inflammatory environment in the gut, as we just talked about, that's an unsafe signal. So that information is going to travel up the vagus nerve to the brain to tell the brain that we have a problem, that we are not safe. That is one of the things that can instigate the brain to create a sympathetic response, and all the cascade of events that we see happens with that. So that information is coming from the gut. So your gut instincts are right. We all know this. You might meet somebody and you think immediately, the moment you see this person, you go, "Ooh, I don't like that person. Ooh, they gave me a really weird feeling." And then that person comes over and starts chatting to you and convinces you they're a really great person. You're like, "Oh, well, actually, no, they were all right. I misjudged. Actually, they were quite kind and helpful and blah, blah, blah." Then 3 weeks later, you say, "I knew it. I knew I didn't like that person. They did something that took you back to that initial instinct." So we ignore our guts at our peril. So this brings us on to the concept of the gut-brain axis. This is that dance via the vagus nerve between the gut and the cranial brain in our head. Now, a lot of people, when they have digestive issues, they end up in a kind of loop. It's very cyclical and it can be very hard to break out of that loop. So when we understand the mechanics of what is happening and how that cascade and loop effect can come into being, then we can find ways to come in and intervene, to intercept into that loop, to break the pattern and reintroduce a new pattern for the gut. People will often say, how long is it going to take to heal my gut? Well, that one cell layer of your gut lining has a very high turnover rate. All the cells in the body are programmed to live a certain amount of time, and then they die off and are replaced with new cells. And the different types of cells have different lifespans. Our gut lining is one of the quickest turnover. You're pretty much getting a new gut lining every 3 to 5 days. So when people say, how long will it take to heal my gut? I can say, well, probably at the most 5 days. And they're like, but I've had this for 15 years. Why am I not getting rid of it? Well, our cells are programmed by the environment in which they exist. If you keep repeating the behaviours that led to your cells getting inflamed in the gut, well, then the new ones will just take on that same program. Every 3 to 5 days, you're getting a whole opportunity to do something new. But if all your thoughts, all your behaviours, all the types of food you eat are perpetuating the same pattern, then that's what you're going to get. So that's why it's important to look at the cycle, figure out how you're triggering yourself into that loop, change the program, and you'll get a different outcome. So let's have a look at one of those cycles. So you might find that you're stressed emotionally, and we've seen how those lower vibrational states create contraction in the body. We also see how when we're in that sympathetic dominant state, the gut is switched off. Remember, it's non-essential if you're getting attacked by a predator. Therefore, anything that you eat, whether it's a poor inflammatory diet or it's the most beautiful organic food you can find, it doesn't matter, because if the food you're ingesting is not being processed, say you've had a meal, it's been in your stomach for 4 hours, now it's down into your small intestine where it should be absorbed, and then suddenly you go into a stress mode because you're doing your emails and something just triggered you, well then the system gets shut down, and anything you've eaten is just going to sit there and rot and ferment. And we all know that when organic matter ferments, it releases gases, and that can explain some of the distension and bloating you might experience, but also produces inflammation, and now we have an inflamed gut. That gut inflammation is going to alter the microbiome. Remember that little bacterial soup that's there in the digestive system, helping to break everything down? Now that's going to get dysfunctional, and we call that dysbiosis. So DYS means dysfunctional, right? Something is going wrong with that biome, and then that's going to add to the inflammatory loop. So that dysbiosis leads to anxiety and depression, potentially. How did that happen? Well, now we've got this little inflammatory party going on in the gut. That information is going to feed back up the vagus nerve to the brain, and remember, it's going to raise the alarm. An inflamed gut equals lack of safety. Brain goes, okay, we need a sympathetic response in case we're about to be attacked. That can manifest as anxiety, but as we saw with polyvagal theory, when it's been going on for a long time, it can also drop you into a depressive loop as well. But guess what? Anxiety and depression can lead to irritable bowel syndrome, right? When you are anxious, now your gut's off all the time, and anything you're eating is just adding to this inflammatory party that's going on in the gut. So anybody that's ever experienced irritable bowel syndrome knows that that's stressful. So now we've got more stress because we're stressed about the thing that we cause by being stressed. And further stress leads to, you got it, gut inflammation, and we're back to where we started. So this is an example of one of these loops that we can get into, and we find ourselves repeating the behaviours and worrying about what will happen when we eat a certain food, which becomes a self-fulfilling prophecy because the stress switches off your gut and then you're going to get inflammation anyway, no matter how good your diet is. So yes, we do want to be mindful about what we eat and make sure we're putting the right ingredients in. But if you're in this inflammatory loop, anything you eat just then becomes what I call very expensive gut compost. So we don't want to be composting in our guts. We need that system to be online so that we can process whatever's coming in. So that's why it is not just what you eat, it is the emotional context in which you eat that is really, really important to address. Don't eat your meal while watching the daily news. Bad idea. So just to bring those images into a little more focus and this idea of the gut having its own brain, have a little look at the anatomy there. When you look at the structure of the colon, it looks very like the surface of the brain, those little coils and loops and bumps. So the anatomy shows us as well that we actually have two brains going on. Now let's transition here to move us into the breath and the respiration, but these two things are inherently linked. Remember, we're all about erasing the lines in the sand of the body whilst we've looked at all these different things, the nervous system, the immune system, the digestive system, and now the breath. While we learn them as distinct systems, they are completely interdependent. That gut lining is your immune system. It is deciding what comes in and out of your body. It is involved with the circulation, with the lymphatic system, and as we saw, also with the nervous system. All of these things are involved in each other's business. When we look at digestion and the breath, what we'll see is that beautiful diaphragm that you see there. This is the muscle that's like a big umbrella in the middle of the body, and it separates the chest cavity from the abdominal cavity. And as you see on the right-hand image there, the lungs are above the diaphragm in the chest cavity, and then below the diaphragm we have all those internal organs. So there's a lot packed in there, and we've only got the digestive systems showing there. There are other organs in there too. When we take a breath in, that diaphragm, the top part of it flattens downwards as the lower part of it moves sideways because the ribs are flaring sideways as we breathe in. Then it has a massaging effect on the gut. The tubing of the gut has muscles in its wall, the smooth muscle, and it has something called peristalsis, where it rhythmically squeezes the food through that tubing. However, those muscles are not particularly strong, and they actually need the help of the diaphragm because it's a huge muscle, and as it pushes downwards, it is massaging and releasing the digestive system. So it's acting like a pump for digestion. So one of the things I will look at with somebody if they're having digestive issues is the function of their diaphragm. Are they somebody who sits slumped over with their rib cage collapsed into the abdomen, and therefore they can't take a really deep breath? Remember, the geometry sets up our structure and the structure governs the function. So if we've got a lovely diaphragm that's able to do a full movement, what we call a full excursion of the diaphragm, then it has a great massaging effect on the digestive system. That motion of the diaphragm also plays a role in activating the vagus nerve and therefore the parasympathetic nervous system. Remember, that's the rest and digest part of the nervous system. So there are many, many reasons why we want to be using the breath, not only for the reasons we'll come on to in a moment, looking at respiration, but also to help digestion.